minutes of very interesting keynotes presentations. And yeah, so I think we are ready to start. And we will start with the, yeah, I need to be the one managing this. Sorry for this.
Recording in progress.
And we are recording in progress. So I have the pleasure, I will start already introducing our first speaker. We are really honored to have here with us today Josef Sivic. And he's the chair of AI Czechia, and you will know more. I mean, he also has many other roles he will explain. And Josef, I would like to invite you on the stage, but also I would like to invite Thomas Hahn, our president, and he's going to put a bit this keynote into context. So big applause for both of them.
So, Josef, first of all, a very warm welcome here. Really happy to have you here to speak about AI in Czechia, but also about Alice, because, you know, there's sometimes always a rumor that, coming from industry, maybe industry doesn't need research and doesn't need real research in the depths like for machine learning Alice is doing. We need this. So, and also greetings from our both friends, Fabian, Thijs from AI Bavaria, heading the Helmholtz Institute. I've seen also a booth from Helmholtz, and you must know with Fabian and Sami and myself, we're heading this initiative, and really looking forward to your speech, and many thanks.
Thank you very much. Thank you very much for the invitation. It's really an honor to be here to open the day today. Today I will talk about the Czech AI research, its impact, and also bring in a little bit of the European perspective in this. And just to give you my background, I am a researcher in computer vision, and after more than 15 years abroad, I came back to the Czech Republic on this come from abroad ground to start a team in computer vision. And also I have been spending in the last few years some time on energy on grassroots initiatives. The first one is AI Czechia, which is an organization of grassroots organization of Czech AI researchers, and also second one is ALICE, European Laboratory of Learning and Intelligence Systems, which is organizing machine learning researchers in Europe. So I'll try to bring in this perspective from these grassroots initiatives into the talk today. I will start with maybe not so good news, and this is, if you look at these graphs, the European AI impact in the research, so these graphs are showing citations over years. On the left is in journals, on the right is in conferences, in comparison to the US and China. These are the other two curves. And you can see that Europe is actually not doing so great in these. The second graph I would like to show is this one, where this is the percentage of international PhDs in AI who actually stay in the US after they graduate. And we can see that this percentage is actually increasing. Now it's more than 60%, from only about 40% 10 years ago. And the question is, what do they do, these PhDs, when they graduate in the US? And what's interesting is that an increasing percentage of them actually are staying in or going into industry in the US. So and now we can see it's more than 65%. So looking at these graphs, we've been thinking, and this is in Alice, how can Europe become competitive in AI in this area? Can we somehow reverse these trends? And so we came up with this sort of three-point strategy, which we think could be a way how to sort of change these trends. And so I will talk through these points, but I will, in this case, because we are in Prague, I will also try to bring in the Czech perspective into this. So the first one is about excellence. And it is really the young research, the sort of young students even, they are really excited about AI. There is lots of stuff happening. They would like to come, but they are really attracted by the talent, by the best people. So we'd like to keep the best people and attract the PhD students. So I will start with the first point, highlighting some of the areas. So it's about excellence, really, and highlighting some of the areas of excellence locally in the Czech Republic. So for some of you, it will be new. So I'll try to tell you, it's not exhaustive list, but there are just few things which I sort of highlighted, which I think are really competitive and can bring excellence on the European level even. So these are the Czech AI highlights. The first one I would like to mention is speech and natural language processing, which is really one of the strong areas of the Czech AI. And just I would like to mention here as an example, and the main two places is Brno University of Technology and Charles University. So Charles University is in Prague. And I don't know if you haven't been to Brno, it's not far from here. You can go and visit, it's a very nice city. But they have a very strong speech team here. And this is from, I think, 2021. These are the top 5 most influential organizations in speech processing. And you can see that the Brno University of Technology is, I think, within the top 5 among some of the very respectable places. So the first one is speech. The second area which I would like to mention, which I think we are doing well here, is computer vision. So this is also my area. And this is showing that the Czech Technical University, you may have heard of the website CS Rankings, which is ranking different universities in CS in different areas. This is in computer vision, and it's based on the number of papers in the top tier venues. Of course, this is not perfect. This is one measure of excellence, which one can use. There are many others. And what's interesting here that the Czech Technical University, or this was 2021, was ranking quite high in this metric. I think now it's still within top 5. Of course, it's a very competitive area. And of course, computer vision is not just it's more to it's not just a niche area of AI. It's actually it's a big area, influential. These venues, this is the main computer vision conference on Google Scholar, is actually within the top 5 of the most influential venues among some of the big ones. And what I also would like to say is that these machine learning techniques are actually similar across different fields. So we are now really seeing the sort of techniques, and this is a paper on the left from a computer. This was one of the best paper finalists from computer vision, CVPR, the top tier computer vision conference. And it is actually a paper about learning on protein surfaces. So it's actually more applying to molecular biology. So it's one example from, this is from colleagues from Switzerland. And on the right is an example of my work applying techniques, again, from computer vision to physics. So we can see that these techniques are really applicable across different areas of science. And I'm very excited about the potential of this impact of machine learning in different areas, like physics, chemistry, and biology. And this is an area which I would like to also mention. And this is more, I will pepper this talk a little bit with concrete examples of research so that there are maybe researchers also here. And this is one of them. So this is a collaboration which I have with colleagues in Loschmidt Laboratories in Brno. And we are looking at applying techniques, machine learning techniques, to molecular biology, and I will show you this an example. So we've been looking at, so we've developed this pipeline to study or investigate the effects of drug candidates on protein dynamics. So you may have heard about this really breakthrough results from DeepMind on predicting protein structure from sequences, from amino acid sequences. It turns out, so this is great, but this is really considering static structures. Often in practice, the functions of proteins is related and tied to their dynamics, how they move. They are actually dynamic objects. And this is what we are looking at here. We are trying to study the effects of the drug candidates on the dynamics of the protein, how they move. And in particular, we are studying this for a specific case of a protein called amyloid beta, which is involved in Alzheimer's disease. It's one of the key proteins involved in Alzheimer's disease. And so I'm just showing you how we're doing this. We are very excited about it. We are just about to submit a paper on this. So these are kind of very fresh results, what you're seeing here. So we are doing, first, we're doing molecular simulation. So this is really physics-based simulation. And we are simulating the protein without the drug on the left and with the small drug candidate. And you can see that these are different. And these simulations, they're producing really hundreds of thousands of simulation frames, which are hard to analyze by eye, by hand. So we are verifying that these simulations, and this is our colleagues in Brno, we can actually go into the lab and verify this, whether these simulations correspond to reality. But then we need to apply machine learning techniques to understand what's actually in the simulated data, to summarize it into a more interpretable model. Then we've developed new techniques to actually compare, because we really need to compare what happens when you add the drug into the drug candidate. So we developed new techniques to analyze these simulations and compare these systems. They are called Markov state systems, which summarize the dynamic of the protein in a compact manner, which is interpretable and can be compared across these different systems. So we are excited about it, and I think really these applications in biology, I see amazing potential here, and we may see, and this is also talking with the colleagues in biology, we may see a lot of progress in this area in coming years. So this was one example. I'm so switching gears. So this was sort of area of computer vision with some applications, of course, now in biology. Another area which I would like to highlight is machine reasoning. So this is another area which is, I believe, quite strong here at the Czech Technical University. So this is team of Josef Urban. They're developing, and here this is from the Stanford AI report, the 3 out of the 5 systems, which are top systems in this area, are actually co-developed here. So if you're interested in this area, you can also sort of engage in collaboration with Josef Urban. And the final area I would like to mention and also give you a few highlights of research is robotics. So again, I'm using the CS rankings here, where the robotics here at the Technical University in Prague is again ranked quite highly, which is great. And one highlight I would like to mention is that the team here at the Faculty of Electrical Engineering, they've competed quite well in this DARPA Subterranean challenge. So I'm not part of that team, but I think it's quite amazing what they've done. If you know the DARPA challenges, they are really difficult to compete in, and this one is about exploring underground spaces. And they didn't have any DARPA funding, yet they were, I think, the best self-funded team in this competition. So the 2 examples, I have also, again, some example sort of research results, which I would like to show. And this one, this is the one which I know is of my work, where we've been looking at learning for robotics from instructional videos. So imagine you have a robot which can, I'll try to play this again, which can just look at an instructional video on the left and then reproduce the task in a different environment, for example. So we've been looking at the robot perception and how to actually then convert the video into a more sort of 3-dimensional trajectory, which you see on the bottom left, and then align it with a simulation environment and use reinforcement learning to learn a policy which can reproduce the task on a real robot. So that's one example. We are, again, excited about this. And what we are looking at is applications of this. I think maybe it comes one more slide later. So this is one more work I would like to show, which I think is also I'm excited about, and it's something which we are now trying to, or others are looking at using this in the Robotics Network of Excellence, Eurobin. So this is one of the modules which we are trying to deliver to the other partners. And this is about, again, perception, where the goal is to estimate a 6D pose of an object given a CAD model. So we have a scene on the left, which the robot is seeing. And we would like to recognize the individual objects, and we automatically can reconstruct the positions of these objects so that they are manipulable easily by the robot. So this is a very important capability for a robot to see what the objects are and directly, so that they can directly manipulate them. So we are excited to now seeing it used by different teams. And I'm showing this because the model which we've developed does work quite well. So these are always, the top is input image, the middle row is the estimated poses, and the bottom is the estimated 3D scene. And this is all from this single image. So so again, we are excited about these results because now the robot really can come in even for a complex scene like the one on the very right, with many similar objects, and still recognize them and manipulate them. And this method actually did quite well in a competition on this problem. So we are now looking also so bringing the European part. We have just started collaborative projects with INRIA in Paris and CNRS in Toulouse, and other industrial partners on applying these techniques in industrial context for what's called a small batch manufacturing. And this was interesting. It turns out of course, the robots are in factories making cars, but in some contexts, the objects are unique. Every airplane is unique, for example, or even turns out elevators are actually made, everyone is almost different to different dimensions. So they're having techniques which can easily adapt the manufacturing line to the specific object is important, and of course then having techniques to reprogram the robot so they can understand the environment, understand the new tasks are important, and we are looking at those in this context. That was about research, and I want to mention one more thing. It turns out actually in AI research, and this is also important for the new coming PhD students because they keep asking, so especially if you want to attract the best ones, do you have sufficient compute? Will we be able to actually do the experiments for our papers? So I think an important part, which is becoming even ever more important, is actually connection between the AI community and the HPC community. So I think there is going to be a session just after this one today in the morning, which will be, I think one of the topics will be this. And I think here we are very happy to report in Czech Republic that we have very good relations. There is a recently opened supercomputer, Karolina, and we have very good relation hosted at IT4 Innovations in Ostrava, and another nice city you can visit. If you are here, you can get there by train easily. So we have very good relations with them, and they were very nice to the Czech AI community, and we together did open calls for compute and make it easier for AI researchers to access this type of infrastructure, learn how to use it, and use it for their work. So I think this collaboration between the AI community and the HPC community, I think, is very important because the compute is actually a very important resource for the research. And I just want to mention a similar, very nice relations were in France, where I was before, with the Jonze supercomputer. I think that was a great example how this can work very well, and where the students and the researchers can have easy access to the compute. So this was the research highlights focused on the Czech side. The second point I want to mention is the impact. So when we want to attract the best students, the best talent, they are not just asking about being able to work with strong researchers, but they are also interested in having a potential of impact, to have entire ecosystem. So when they graduate of companies and research startups and research labs. So when they graduate, they can actually easily find a job. So I would like to here mention again few highlights which I think here sort of locally are interesting even on the European level. So the first one I would like to mention is from, again, the speech and natural language processing community, which, as I said before, has a strong sort of research basis, but also it turns out they have a lot of kind of entire ecosystem of speech and NLP companies, research labs, both big ones, as you see some of the big names here, but also startups in this area. So I think this is very exciting. Another example I would like to mention is this National Center of Competence in Cybernetics and AI. Again, it's a collaboration between universities and companies of different sizes, small and big ones in the areas of AI, machine learning, but also robotics. I have a few slides here of the two types of impact which can happen. They are taken from Prague AI, which is a local initiative, sort of kind of focusing on the impact of AI bringing to researchers and companies. So the first one is businesses going global. So here are a few examples of Czech AI businesses which have attracted significant funding recently. I will show one of them even later. So I think this is great. We are excited about this. This can happen. And second example are more global businesses now coming to Prague, interested by typically the talent and the research here. And again, looking at this list, maybe to highlight, you probably may have heard about this merge of the really global giants and cybersecurity, which is very much driven by AI these days. Avast and NortonLifeLock, which is on the level of $8 billion US dollars, so it's a huge thing. Another example, there are two French companies, Atos and Valeo, who really have now come to Prague, and I will mention Valeo a little bit later. So we are also excited about these opportunities. And in the end, it's not just the companies, it's entire ecosystem. And here I think I would like to praise locally here in Prague, Prague AI, but in other cities, there are other initiatives like Brno AI, which are really trying to bring the whole ecosystem in AI together with the, of course, the startups, but also the capital education on different levels. Also, not just for researchers, but also for professionals. It's important for having AI impact. And of course, networking and expertise. So the ecosystem is very important. And here are the few of the examples I would like to highlight. So this is Rozum, is a startup from students from the local Prague universities. And they found a niche, an opportunity in document processing. So they may be automatically now it's really computer vision techniques might be processing your invoices now. They've raised a significant amount of funding recently. And I hope, and they seem to be on the trajectory to become a sort of Prague AI unicorn in this area. So very excited about them. Another example is Phonexia. This is a Brno-based company who is really, and this is what I'm hearing from Jan Černocký from Brno, it was a spin-off from the university. And from somewhat humble beginnings, they really now are one of the leaders, if not the leader, of speaker identification. So speech processing technology, shipped their technology to more than 60 countries. So Phonexia, another company to watch. Another example I would like to mention is, I'm sorry, I need to go, is Valeo. We collaborate, so Valeo, it's a global automotive company, but they have an R&D center here in Prague with more than 700 employees. We collaborate with them. It's very exciting to really work on the cutting edge of autonomous driving. And another example I would like to mention is this International Neurodegenerative Disorders Research Center. This ties into some of the example of the machine learning for protein engineering I was mentioning earlier. So here, really, the neurodegenerative diseases are a major burden and an amazing opportunity with no really or very little available treatments which would work well. This is in collaboration with the company Alzeon, which is US-based, but is with Czech roots. Here you can see on the picture Martin Toller, who's the CEO of the company. And they've initiated here this research center to really push the boundaries of what's possible in the treatments. It's just beginning, but I see again here a potential for global impact if we sort of manage to make progress in this area. And finally, I would like to, so we saw research impact focused on the Czech sort of Czech background here. And finally, I would like to really tie this more to the sort of the European context. And I think here we really only have a chance to be competitive on the global level if we work together, you know, across different countries. And here I would like to happily report that the Czech AI is very well connected to Europe. And I'm sort of highlighting here several of the initiatives you may see, and I think in this room there are many people involved in these. Just maybe this picture on the left just recently started this summer, a network of excellence on robotics. And because this is mainly my background, I would like to say a few words about ELIS, about European Laboratory of Learning and Intelligence Systems, because I was, I sort of know most about this. Here, again, and we do strongly believe that we only really stand a chance on the global playfield if we work together, and focusing on really being able to attract the best talent globally to Europe and create competitive conditions for them. And in this, we sort of have 3 pillars, which I'll also very briefly introduce and give you a quick progress update in the few minutes which I have left. So the first one are the research programs. Really, they are inspired by the very successful CFA research programs. So currently, we have 14 of them in different areas of machine learning, going from really theoretical underpinning to more applications like in health or climate science, sustainability. Each of these programs brings together around 20 really top researchers in that area in Europe, and they meet twice a year and discuss and really advance science. But not only advance science, they also act as sort of typically in their local ecosystems as ambassadors of AI and machine learning in their local ecosystem. So they have a lot of the programs they had because of COVID workshops online, but it's excited to see it's beginning to really to have in-person programs, which I don't know if this is an in-person event, which is great. And I've been also to scientific in-person events in fall, and it's just wonderful to meet people again in person. So the second point I would like to mention or second pillar of ELIS are the ELIS sites. We thought, well, how do we really bring the local ecosystems together? And so we created this call for what we call ERIS units. So ERIS units is a local sort of physical laboratory which brings researchers maybe from several different institutions, but locally in one place. And so we came up with a set of criteria so that really we can ensure excellence, that they are competitive on the sort of global level. So we have a review process where and we have regular calls for these units where a local unit can apply to become, or a local ecosystem can apply to become an ELIS unit. So we started in 2019, and we thought, okay, maybe we'll have few applications in the call, maybe 5, and it will be great. And sort of about 3 years later, we have 35 Alice units across 14 different countries and covering, I think, some of the important AI ecosystems in Europe. So we are very happy about this. What we want to work on now a bit more is to expand. You see that the coverage, some areas are maybe missing, so we would like to expand this more towards east, for example, or maybe towards also south of Europe to cover also some of these somewhat underrepresented areas. And so one of the calls was this year, and it's happening, and the new units should be announced fairly soon. And finally, what I would like to mention is this LS PhD and postdoc program. And I think this is another example where if we work together, we can really become competitive with the best places in AI in the world. And so how this works, so that we have it's like a meta program where students apply centrally. So there is like a central reviewing process where students apply. And actually the goal is to become like really the place for international students that would attract the best students globally. They can, a single place, they can apply for places in Europe. And the idea is that each of these students, they have to come through this recruitment process, but then they have 2 advisors in 2 different countries, which typically would provide complementary expertise. And the student have to spend at least 6 months in another country working with a different person. And the second track is more focused on industry, where the student spends at least 6 months in an industry lab. So they have an advisor in academic lab and an industry lab. And so far, we had the one round has just finished. One round just finished, and so far we had about 3,000 applications to this program. And I think really this is a place where if we bring top faculty from Europe together, we can compete with places like Berkeley or MIT because we will have the critical mass. And with this, I would like to really thank you for your attention, and thank you very much.
Thank you so much, Josef, and he will stay with us during the break, a coffee break, so questions please approach Josef during the break. Thank you. So we moved from the AI world to actually an organization that is worldwide and working more in industrial AI. And I have the pleasure and the honor to invite on stage Stefan Hoppe, who is president and CEO of OPC Foundation. Thank you for being here with us.
Thank you so much. You can hear me on this microphone? Yes, okay. Good morning, first of all. It's a pleasure to be here because normally I'm only living in my bubble where I'm always traveling in industrial automation shows. And it's really the first time that we are here in a big data event. So we are the newbies here, right? Here's a clicker. And my message is, normally what big data and artificial intelligence is, you are looking to a bunch of data, you're collecting first data, and then you run all your mathematical mechanism to find patterns, and then analyze the process, and then optimize the process overall, right? This is a short summary from OT point of view. And my message is, hey, we, the OT industry, we can provide you much more detail because we provide you the semantic information that you already know what's the meaning of the data. So you can be much more efficient, much quicker, much better in the future. I will go very quick through the organization, the technology, a little bit security. Main topic is semantic, obviously, and then also a lot of offerings for the academic world, because I figured out at this conference there's a lot of academic people. And before I do this, honestly, the OPC Foundation, I figured out, is maybe one of the few organizations here today which has completely no public funding. Everything is paid by member fees only. So the OPC Foundation itself has a vision to, in a secure way, reliable way, move standardized information completely independent from the vendor, from the market, from the operating system, from the hardware, from sensor up to cloud, between cloud systems and back. And the range, you see that secure and reliable is mentioned first, because if something is not secure, the rest has no value. connectivity, interoperability, semantic has no value if it's not secure, right? Specifically, right now with the war and cyber attacks, we realize the importance of industrial security. Again, the OPC Foundation is a non-profit organization. It's a hotspot of OT and IT companies around the world. And everything what we deliver is open. This is the O from OPC. We provide specifications, and once they are released, they are open, available for everybody. You don't have to be a paying member of the OPC Foundation to get the specifications. We provide sample code. I'm talking about that later as open source. And also our certification lab is open, available, even for non-paying members. You have to pay the person who's doing the test, obviously. Somebody has to pay him, yes. But the OPC Foundation is not earning money with that. We don't want to earn money with standardization. We want that the product in the field have a higher reliability and just work out of the box to reduce efforts for the industry. And this is why all the big industry vendors are inside the OPC Foundation, because at the end, they are saving money, because they don't have to support 20, 50, 30 standards, instead the one big one, which is providing everything. The board of directors is voted democratically. Also, I have to be re-elected this year. So cross fingers. I'm really proud to represent more than 895 members across the world from OT and IT. And so I can really say this is the world's largest ecosystem for industrial secured interoperability. From the top 50 OT companies, we have 85% in our membership. So the who is who, Siemens, ABB, Rockwell, Schneider, and are members of the OPC Foundation. But also from the OT world, the small companies like Amazon Web Service, Microsoft, SAP, Google, IBM, and so on are members. Big end users, Foxconn, Volkswagen, and others are members. We are still growing, even in the pandemic. That's good message. First of all, what is OPC-UA? And maybe I have to clean up a little bit your brain. Allow me to mention that OPC-UA is not a protocol. We have so many protocols, we don't need more, I guess. And there's not one single protocol being able to fulfill all requirements. Because you sometimes need, for the OT world, a field bus system with dedicated real-time in a super small microsecond range. And these field bus systems are not scaling to cloud. And perfect cloud technologies like MQTT are not fulfilling what is required in the field level. So there is not one single protocol in the world fulfilling everything to move data from field up to cloud. And so in the old pyramid on the left side, you have always media breaks, because you're always converting data and then have different other protocols in that specific layer. And with OPC-UA, in the middle of the graphic, you see that we have a mesh network where you can even bypass layers. The sensor can move data to the PLC or to the SCADA system, or directly or in parallel to cloud systems. So it's just the configuration of the connectivity which gives you all the freedom, what you like to do and what you want to do. So OPC-UA is not a protocol. OPC-UA is a framework which allows to move standardized data over these different protocols, MQTT, TCP, and 5G, and whatever is coming up in the future, and we don't know, because a super smart student has a great, brilliant idea in the future, right? So it's extendable. What we are doing, and this is what I'm talking later on, is we are partnering with more than 85 other associations, because they bring in the domain knowledge about how to describe a robot, how to describe a pump, a motor, whatever. I'm not going through all these topics, but you get the slides and then you have an idea. But OPC-UA as a technology, as mentioned, is open, is independent, it's international. It is an IEC standard. It is scalable from sensor to cloud, cloud to cloud, cloud and back. It provides modeling capabilities to describe the thing. Because if we are living in the Internet of Things, you first need a description of the thing. This is what you should be keen on, not just collecting big data. You want to know what is the data about, the description. Security is baked in. Transport, we have multiple transport patterns because, again, I mentioned before, there's not one pattern only available. So it's client server, publish, subscriber, and all fancy stuff behind the curtain. Robustness is baked in. Even you lose a physical connection, it does not mean that the data are lost, because automatic buffering mechanism and flight recorders will start in the background and will buffer the data. So security, I mentioned that before, is baked in by design. And again, I don't go through all the details, but overall, the security is built on 3 pillars. Pillar number 1 is it's security as an enabling technology is baked into OPC as built in by design from begin. It is not only security on the transport layer, it is also on application layer and user level who is allowed to see what kind of information. Everything is available also for audit mechanisms. The second part is continuously monitoring. We have about the 25 best security experts of the world from the big IT, OT companies who are doing weekly meetings to review what happened in the world. Are we infected? Is there an issue? And then they also do recommendations how to improve the standard, bringing in new standards like ecliptic curve cryptography, which allows in super small hardware-constrained devices a better computing power on calculating on keys. And last but not least, we have also education and guidance, because security is so complex that the worker at the machine is completely overloaded with information. So we reduced everything to one single page. This is the cookbook where you need to be aware and check these are the security settings, be aware to activate them. And we have been super proud that we have been reviewed by security experts international, meanwhile the second time by the German BSI, because of the relevance of OPCA for the German industry. But also the France government contacted me. France want to review the OPCA security mechanisms built in, and we also have contact now to Homeland Security in US, because they also figure out cybersecurity and security mechanisms are critically important. Because it's here big data, I'm not talking about the field level, more on how to move data to cloud in a very quick system, in a very quick overview. And you see here all the logos from all these small cloud giant companies. And in a second, you know why. Overall, the OPC Foundation has a cloud initiative. I'm not talking deeply on all the topics. The cloud library, for example, is, from my point of view, the world's largest repository of OPCA-based information models, which is free available. It has a REST API. You can just go there. You can search for the motor, for the robot, and you can download the information model, which has been done by experts. But again, it's open. It's free of charge. So which means you can buy the pump, and while the pump is on the way to be delivered, you can download the pump information model, and you can start on your IT level and prepare all of your services. Cloud federation is how 2 cloud systems can talk to each other, because sometimes from your side, on the left side, manufacturers don't allow that all supplying parts, motor parts, are directly published in multiple supplier clouds. Instead, what a manufacturer wants to be on the right side, first of all data go to my own manufacturer cloud, and then I decide which kind of information is forwarded to others. And we are working on this with the smallest cloud giants of the world. Last year, in 2021, I was super proud. I was really excited. This has been a dream, which I thought will never happen before I retire, but it happened. That we even can directly talk from controller level up to cloud. At that time, Siemens and the backup controller have pushed OPCA over MQTT directly to the cloud, at that time only to the Microsoft Azure cloud. And the reason why we did it, because you might think, hey, MQTT is so popular, why don't they just talk MQTT? MQTT is what everybody has, right? And you are right, everybody has it. And by the way, we love it. The OPC Foundation loves MQTT. It's another enabler for us. But MQTT is not, it's payload agnostic. If you ask multiple companies to push the sensor 1 and 42 as a solution for everything to the cloud, you will have different patterns, and you always need a little bit scripting. And now you are the IT people and say, but that scripting is easy, and you are right. But we want to avoid all of these extra converters. We want to just have plug and produce. At that year, 2021, again, 2 OT companies, 1 IT company, but we had the announcement from all the big cloud giants to support it in the future. That was amazing. And this year, in 2022, we have 18 OT companies, all the big SPS, PLC, and Motor, and KUKA, and others, pushing data, and also the AWS cloud giant supported this. So we had 2 dashboards at the trade show, and all the companies can immediately, without any additional engineering, without any conversion, directly push data into cloud systems. We not only provide JSON, also binary for security reasons, but that's going much too into detail. So, bubbling up again, talking about information modeling. Let's think about OPC-UA is this framework, like the Lego collection bricks, and every Lego brick has a specific functionality for discovery, modeling, security, what I talked about. And this is not easy to order. How do you order a robot with this and that functionalities? You cannot order, like if you build Lego, I want to have 20 red bricks with 8 bubbles on and so on. It's too complicated to order. And you need the description of things, the semantic, to know what the data is about. And so this is where we work together with others, partners, associations, and they define the companion specifications. What you see here, the pre-packed Lego packages, which gives you the super user experience because every even stupid person can build up these packages because they are pre-packed, everything is inside what you need. You open the box, you present it to somebody, and just a few hours later, the Lego part is done. And this is exactly how you then can order it. I want to have the KUKA robot, and the KUKA robot should support the OPC-UA robotic companion spec. And inside that description, every Lego brick is mentioned what you need. And this is also easy to check and support by suppliers. Overall, there are 85 information models available. I mentioned that, free of charge, accessible. And this is why I believe this is the largest ecosystem in the world for information models for the industrial automation world, obviously not for other areas. And if you want to have a good overview and you like to search for something, there is a web page on the OPC Foundation where you can even filter for companies, you can filter for different vertical markets and technical features, so everything is available over there. I'd just like to mention one as an example because this is now upcoming. We are working on power consumption, again, together with others, with the P&O and ODVA, field bus organizations, but also VDMA, which is the European largest machine builder association. And it's all about to have a common understanding of how to describe energy data in machines, because I believe that we have so many different descriptions. We have nearly a war or a fight, let's call it a fight, on different information models. And this is what we don't want. We want to have agreement, working together. I absolutely support, we need to come together and work and cooperate together to have a common understanding on this is the data consumption, because all devices, all assets will have a power management interface in future, and it should be obviously the same. To address here the academic world, I want to provide a little bit information about open source offerings and general open offerings. So one is the OPC Foundation is providing open source. It's a .NET standard sample code which is available free of charge on GitHub. But just at this SPS show a few weeks ago, we have been made the announcement that 3 of the board companies on the board of directors, ABB, Microsoft, and SAP, because they are using this open source in their productive code, they came together and said, let's have joint forces and every company is spending 1 full-time developer resource that they can integrate new features, increase quality, and have a kind of a project management on this open source. I'm proud that the license is not changing. It will completely stay open source. There's no change. Everybody has access to it. And so I see a lot of positive signs going on here. The second one is, if you like to start, and if you like to start with your students maybe, there is a free of charge so-called IIoT starter kit based on OPCUA. It's running on a Raspberry Pi base, and it provides exactly OPCUA over MQTT, what I mentioned before. And it has 3 examples on board. I believe just downloading, putting it on a device, playing around, will take then less than 1 hour. It would allow to immediately push data to Microsoft Azure or AWS. And I assume, but I can't announce it, that other cloud giants will provide it next year. Oh, by the way, I forgot also, there was even a hackathon with 20 devices with Siemens MindSphere. So Siemens MindSphere is obviously also supporting this, but we haven't shown it public on our booth. But I think this is happening then at the next trade show, Hannover Messe, next year. The last one, which is also, I believe, super exciting for you, is we have a public, open, available OPCUA academic program where we have about 260 slides addressing modeling, security, data connectivity, distribution of certificates, and so on. Everything is covered, and this is even provided with an explanation by a professor how can you explain it to your students. It is under a license that you can steal all the content. We invite you to steal content, graphic, whatever. You don't have to use our OPC Blue Slide Master. We want that young people get educated because specifically in Germany, there are a lot of companies looking for people and young people who have OPCUA knowledge, and you don't find them on the market. So this is our help on the academic world. We have, right now, we are even translating it into different languages. It is available in Chinese language already, but now we do it in French, Spain, in Japanese and Korean language also. Last but not least, before you say, hey, there's a big world outside and they are not connected with OPCUA, what to do? Hey, remember, well, the young people will not remember, I'm sure. So I'm just looking to the young lady here. Whenever you bought a computer, it had USB connectors, and this fancy stuff doesn't tell you anything. I know, but I'm the older one, and at that days, the keyboard had a different connector than the mouse and the printer. This is exactly the connectivity challenge we have. And what are you doing if you have old stuff? You are putting a small green adapter in between. So there's a huge marketplace on adapters where you convert Modbus to OPCUA and so on and so on. There are success stories on the OPC Foundation web. There are brochures, so download that. But obviously, we are here at the. We have a booth here, and we have experts there. My last slide and call for action. We have so many keywords, and when I listened here yesterday at the conference, I learned about so many new keywords which I have never been aware of. And my feeling is that on the one side, the academic world is super aware of that, and the super large enterprise companies are super aware of that. So Siemens is everywhere, and they know everything, right? Okay, and that's good, by the way. That's good, because only if you understand the world, you can provide solutions. So they have to do it. Don't misunderstand my message here. But the super small, medium-sized companies, my feeling is have no longer chance to follow up and figure out where to start in this jungle of standards. And this is why we like to help with big pictures. We cooperate with others to give this big picture interoperability. And my last statement, I figured out that in the OT world, a lot of agreement has been done to cooperate, to come together, to only work on one information model for a pump and only one information model for a robot. But what I realized is, when we are talking to others, to the IT people, they are also starting with a different point of view to a robot, writing their own information models. So the technical people write the information model from the technical point of view. This is how my robot looks like, and these are the technical capabilities. And the IT people write the information model on the robot should do this job, and this is my business. And instead, they are coming together and agree on the modeling language. My feeling is everybody's starting from scratch. So let's come together, avoid to redefine the world and cooperate more. This is my call for action to everybody here. This was my presentation. If you have questions, visit us at the booth. Thank you.
Okay, thank you, Stefan. Maybe 2 words. When you look at the OPC webpage, you will find also my name. So I'm on the person also on the board. And Stefan explained to me, look, I'm going to the European Big Data Value Forum. And my first reaction was, what? So that was my first reaction, so what? And then I said, maybe not a bad idea, because, you know, data, to get value out of the data is, let's say, our home turf, and supporting, let's say, this with connectivity, with a framework, with companion specs, with describing this, is helping us. You are touched a lot of in manufacturing domains, it's also the home ground, but I know also in other domains like health, like think about our kitchen experience, connectivity, energy you mentioned, also in a lot of other domains is coming relevant because it's helping us. So that's all my word. And
don't start modeling a coffee machine. It's already done.
Exactly.
Right? Thank you so much.
Thank you so much. Thank you, Stefan. Thank you, Thomas. Again, very good to put things into context. So now I would like to invite our next speakers, and now we have 2 speakers on stage, and I would like to invite Susanne Stenberg and Håkan Burden. And they are from RISE, and welcome. Thank you. Big applause.
I don't know. Do we need the mic? Probably.
We probably need the mic.
And I cannot stand still, but I'll talk here, and if you cannot hear me, I'll just shout. I'm going to move, so thanks. Okay.
So, yes. So we're here to tell you why you should care about what's happening within the legal frameworks and why that is also a very fascinating place to be. So I think it's...
Okay. So our research is focused on how is the market changing due to policies. And you will get our takeaways first. And then we'll see if you can get the crash course of the reasoning also. It depends on time. Okay, here we go.
Here we go. So this is our first takeaway. Data is becoming a tradable asset. Just like we already have freedom for people, money, and products, we will have freedom for data. This is based on what we see in the upcoming legislations, but also when we talk to people responsible for those legislations, we can see this happening.
And yeah, maybe you can read at the same time, I guess. So we'll just pick out some of them. One interesting is that the concept of understanding the market is changing. How do you assess what's your market, the relevant market? So you will have to understand the coming policies to do your strategic choices in your business. For instance, CE marking is now entering the digital domain, which has not been before unless it's inside a physical product. That means different things in different organizations. Next one.
Next one. So takeaway number 2. EU as the front runner of regulating digitalization. So I guess that some of you are used to being regulated by the UN ECE, or if you're within shipping, you're regulated within IMO and so on. But we're seeing that within business is traditionally regulated by other international organizations. The EU is now becoming the front runner, and it's fascinating.
So when we dig into the official documents, analyzing the guidelines and rules, the binding rules, comparing the international rules from the UN organizations with what the EU is delivering now through the digital decade, just pumping out new rules. The EU is becoming the front runner of regulating market for digital systems. This is new.
So these is just some examples that we found from our analysis. It's not like the complete list or anything. It's just examples of how the EU is filling the void where other regulators have missed important things to regulate.
And it's our analysis. Someone else might say something else. Okay, number 3.
Number 3. This might be a bit more difficult to comprehend, but we can see how the national authorities are becoming major actors within the innovation system.
And that implies that if your organization will do business on the European market, and if you are yourself doing the research and development for the products that you want to provide on the European market, you will have to step back and think, how are my relationships with what authorities? Which authority might be part of my innovation process? And what kind of competence do they have? What kind of competence do I have? Will I need to work with more people, more organizations in order to be part of this new innovation ecosystem?
And you might have people on board that are really good at collaborating with national authorities when it comes to the market surveillance part of their assignment. But do you know how to collaborate with them in your innovation process? That might be a very different skill set.
And do they know that? Do the authority know that?
Yeah, definitely. So our last and final takeaway, we call it a triangle of trust because that is a known concept, so we just hijacked it and used it for another purpose. So it's a three-folded or three-tiered model of trust. So we have the CE mark, we have the national authorities, and we have the regulated responsibility. This is a strong trend from the EU that we can see.
So from products to fundamental rights, if you're dealing with some kind of different levels of autonomy within your system, if you have that within a product, you're probably used to certification process. If it's not within a product, it's within, I don't know, education or the healthcare sector or something, then this is a new thing to understand and get into your organization. How do you certify an AI system?
And you can see that we have standards in two places here, right? So we have standards under the CE mark, and we have standards under regulated responsibility, and we can see that they play two different roles here. So in the first case, we see how these high-level discussions on ethics and values are encoded into law, and then how the law is pushing or pulling, whatever terminology you want to use, for new standardization initiatives, fulfilling those regulations, those laws. So this ethical debate that we're having at the moment about what's responsible software development, responsible AI development, system development, is going through the regulations down to the standards. So that's where you want to be in the future, making the next generation of standards. And in the other case, we can see how specifically the AI Act says that you go through how the negotiations have been, and in the beginning, the Commission had the right to push out for common specifications if they didn't find that the harmonized standards were good enough. We can see now how harmonized standards have been the first option. So the industry has take number one, but if you don't deliver, the EU Commission's common specifications is the fallback. So we will have the EU Commission, again, filling the void of whether your harmonized specifications don't deliver. So a regulated responsibility. You will be responsible.
And this is also a way to see how ethics ties together with what kind of technical standard do you use. So standards will be, of course, very important to take an active part of what do they look like, what do they entail.
And we will show you an example how this works in reality.
Okay, now you got the 4 key takeaways. So we'll take the crash course of the reasoning to get here.
So it's based on what's happening in the digital decade. And we've been looking into the different acts and the negotiations behind the different acts and interacting with different stakeholders, what they see, what we see, what can be thought of as happening when we start implementing these acts.
And so there's a lot of policies and acts coming out, and there's at the same time also funding, of course, of building the infrastructure, cloud and edge, for instance. So it's a cooperation here. Yes.
So freeing data, we've been talking about data as a tradable asset, and you should be feeling wow, just like when the orca jumped into freedom, you would say, oh, wow, data is jumping into freedom. That's the sense you should be having.
So we have 2 things, right? We want to get access to data, and we want to have a responsible use of AI and robotics. The first one, access to data, free data. But how to do that? But it comes again and again in different new proposals, where you can see signs of this. An active way of regulating the market, reshaping the market.
Or the AI regulatory sandbox. So this is a very Swedish picture. I don't know if it carries well across Europe, but this is just what Swedish kids look like when they're playing in the sandbox.
Now this is new because this, here again, you should do this together with an authority, a national competent authority.
Which will assess if your idea is good enough to be in the regulatory sandbox, and if your idea is good enough to have access to the benefits of being in this accelerated to the market. So a national authority will make that assessment, not you.
And if you are developing your software within this regulatory sandbox, you can also have legal exempts, for instance, from the GDPR. This is also a new concept, that if you develop software together with an authority, you can get exemptions.
And the last point here is interesting because it also says explicitly in the AI Act that the reasoning behind establishing a regulatory sandbox might be training on being compliant with new legislative requirements, but the motivations for creating a regulatory sandbox are much bigger, include much more topics than what is seen as high-risk AI and warrants compliancy.
So there's an element of common good here. Society wants AI to work for the good, so there's why. That's our guessing, or at least that's why.
So, our very technical slide. So here you can see we tried to map out how we reason about high-level discussions on ethics and values and how they are encoded into law, EU regulations that will be, in effect, national law without passing your national parliaments, and how they will trigger standardization initiatives.
So these are examples taken from the proposed AI Act, then, so one can see, yeah.
We have Article 10, technical requirements on data, and then you can see the reasoning behind that. If you go into the recitals, the motivation for the AI Act, you can see we shouldn't have biased AI systems. And a way of ensuring that our systems are not biased is by having good data sets. Okay, let's make good data sets a legal requirement. And then you can see if you have the same reasoning for Article 14, the human in the loop, possible interventions. And if you move down to Annex 4, you can see, well, these need to be connected. So the standardization initiatives and the upcoming standards need to be connected to the different technical requirements that are postulated in the articles. So it all ties together neatly in Annex 4. It's brilliant reading.
Technical, but necessary if you want to provide your software on the European market.
And then in Article 49, you place your CE mark visibly so that everyone sees that your AI system is compliant. If you've seen the little robot carrying dishes in the lunchroom, that's CE marked.
You can look for it at breakfast tomorrow.
It's on the base of the robot. You can see it's CE marked, and in 3 years' time, that will mean that it has a really nice, compliant AI system in it as well. So the reasoning is the CE marks entails that we have ethical AI. This is our last slide. So just wanted to say...
Oh, it's not, but it's almost the last slide.
Anna says it's our last slide.
All right, then. Cecine Spain Pipa. So you need to, the takeaway here is there's a definition of AI within the proposed act. You can think whatever you want about it. You can discuss that, but you have to relate your business to it. EU decides what's an AI system. There's new ways from idea to market. You can think whatever you think about it, but EU decides you have to relate to that if you want to be a provider on the European market.
And EU will decide new contractual agreements when it comes for data sharing, and you just have to accept that. You can think what you want about it, but the EU decides.
And you can, of course, take part of the shaping of this. And that's why we're here, right? Sharing what we see and discuss with you. Okay, we go for this very, very, very short. It's just changing the game.
And we've survived game changers before.
So it's nothing to be afraid of. It's an opportunity.
So things will change. That's an opportunity to be part of that change and model that change so it fits your needs.
Thank you. Thank you.
Thank you so much. So again, during the coffee break, a lot of reflection with all these ideas. So you can find Susanne and Håkan around as well. So now our last keynote speaker for today represents Dawex, the company Dawex, and is Laurent Lafaye, and co-founder and co-CEO of Dawex. Thank you for being with us. And this is the next slide. Sorry for this. Well, is it already your slide? Sorry that we didn't put your... Here you have it.
Okay, thank you very much. So I'm Laurent Lafaye, an entrepreneur for 15 years now, and the co-CEO of Dawex for 7 years now, and a member of BDVA for 6 years. So thank you very much, Anna, and thank you, Thomas. and thank you, BDVA. So at Dawex, we are very involved in two European topics. The first is Data Governance Act. We are talking about from yesterday in different conference. And I will explain how we cross the regulation, Data Governance Act, and the principle of Gaia-X. Gaia-X is a European association of industrial, of tech, cloud, and many usage in different verticals. And I'm trying to explain the convergence of these two European initiative, regulation, and industrial commitment. So Dawex, we are a tech company for data exchange to enable organization, private company or public bodies to grow data ecosystem thanks to data circulation. So in our world, the key words are data exchange, data marketplace, and data hub. And we are today 50 people. We have clients in more than 15 sectors, and we have offices in France, Montreal, and very soon in Japan, because we have customers in this country for 3 years now. We provide a SaaS platform called Data Exchange Platform to create this kind of data ecosystem, data hub and data marketplace. And we integrate all the customer journey for data provider, data acquirers, to exchange data on managed mode or distributed mode. And we put in place several business models around data exchange. So we have a lot of experience in of the topic of how monetize the data or flow the data in a securely and traceability mode. We are also involved in Gaia-X. We are day one member. So Gaia-X, there is two topics. The infrastructure ecosystem side, of course, with cloud provider and how Europe grow champion in Europe about cloud, but also regarding technology around data ecosystem. And one of these technologies is data exchange. And so we are part of a working group called Data Exchange Services. We lead this working group with IDSA. And we supply our technology to one of the lighthouse projects, Ag Data Hub, in the agriculture field. So this is a schema explaining the data value chain, very simplified. So on the left side, all the topic concerning data collection, data aggregation, etc. On the right side, the usage of data and how to build business use cases. And of course, it is a loop. We put in the middle to explain data exchange with the concept of trusted data transaction is a way to support technical exchanges of data, but also licensing, because it's a question of IP, business model on each data transaction, and compliance, of course, with regulation like GDPR, but also with the new regulation like Data Act. So in Gaia-X, we are a group of, I think, 30 tech company or vertical company from banking services, energy, agriculture, food, extra. And we define specification around what we called data exchange. And the trust framework, we are calling a lot about what is it, trust. The trust framework is a Gaia-X cornerstone. It expresses all artifacts participants, services, data products, following standardized formats called self-descriptions. A self-description is a standardized JSON-LD file structure with attributes, and the trust framework usage is mandatory for the compliance with Gaia-X. So verifiable credential are instantiation of self-description where attributes are signed. They are used to ensure transparency, security, and trustworthiness. So in these data exchange services, all the information we see are published. We define the vocabulary. What is it, a data producer? What is it, a data provider? A data exchange, a data product. So it's the way to create the beginning of a standardization about data exchange. And we are working also around licensing and policies. What is the definition of data transaction traceability? Because traceability is part of trust. And how we put in place discoverability of this data product. So it's an ongoing working group. The first release of specification was, I think it was last week. So that's for the DGA, for the regulation part. So there is two major regulation. Ivo Volman talked about yesterday. So the first one, Data Governance Act. Data Governance Act creates the third party of data exchange between a data provider and data acquirer, which calls the data intermediary service provider. It's not the holder of data, is the animator of the ecosystem of data. And the second regulation, so Data Governance Act is already adopted and in application next year. Data Act focus on data accessibility, especially on connected data. It could be a satellite, it could be a vehicle, it could be everything connected, and focus on the two parties in the data exchange, so data producer, data provider, and data acquirer. Is proposed for the moment in discussion, and we hope adopted very soon. So these two regulations will be mandatory to comply to operate this kind of data exchange. So the solution, the tech solution, has to implement the law. That's why for European tech companies, it's very important, these two regulations. And these two regulations are very complementary of what we are doing in Gaia-X, because there is it's the association of course, regulatory framework, Data Governance Act and Data Act, but also about reference architecture, what I have described previously about specification of data exchange, but there is a lot of specification currently down in Gaia-X. And security framework in Gaia-X we call labels. So labels are Gaia-X services are described by the attribute of verifiable credential. When a user looks for a Gaia-X compliant service, he may require a level of trust based on the attributes of VC. And labels are based on 63 criteria using attributes for VST. For instance, it could be ISO certification, European storage, etc. They are issued for service offering only and ensure that a predefined set of policy and technology requirements are met. And these labels go from 1, lowest requirements, to 3, highest requirements. This is an example of implementation in Ag Data Hub, so the agricultural data hub in France and deploying in Europe of how we implement the trust framework of Gaia-X, especially VC. And it's just a screenshot, and it's just to explain that it's the beginning of how you create trust in this kind of platform, and I think it's the beginning of what we will see in the future for data spaces, thanks to the working group of Gaia-X and its specification. So do not hesitate to download these documents. They are publicly open to all. Of course, you have to be a member of Gaia-X to contribute, but they are accessible to all who want to understand this specification. And that's all. Thank you very much.
So, Laurent, many thanks that we are somehow together in a cooperation on this journey, interesting journey, I can tell you what we are doing together. And as said before, you mentioned Gaia-X, I mentioned yesterday also Data Space Business Alliance, we are IDSA, FIVE and BDVA, really pushing this forward in a very collaborative way, and think about the words from the minister, open and collaborative, trusted. You can add a lot of topics, but exactly that we want to do, because then we're creating really impact. And Anna, I think you make very briefly, and many thanks.
Yeah, it's just we are about to go to the break, but I just want to make sure that people who are here, who will be then in the plenary, in the parallel rooms, but still they can come on stage to say a few words, because we always talk about our collaboration partners, about our, and it's just please 5 minutes, and for some of them this will be spontaneous, but I would like to welcome the Executive Director of the Euro HPC Joint Undertaking, Anders Jensen, to say a few words, and there is maybe a couple more short and sweet and short, because I have someone else to call on stage. Thank you.
Thank you very much, Anna. So first of all, thank you very much for the invitation. It's been great to just the time I've been here to get an insight into your ecosystem, and it gives me, a lot of hope for your contributions to Euro HPC. So I'm just going to spend, I know I'm between you and the coffee break, so I'm just going to spend 2 minutes to explain to you what this animal that's called the Joint Undertaking is all about, which, by the way, you're now part of, because the reason that we've been invited, amongst others maybe, but is that BDVA is now one of our private members, and therefore contributing to the Joint Undertaking and our strategy. So the Joint Undertaking is a special vehicle that has been created by the European Union, and it's called joint because we do everything jointly. And essentially, what I always like to brag about is, I have 3.5 billion euros to spend, which is great, but we're joint up. So every time I spend €1, someone else has to spend €1. That's the key, and that's actually what makes the job very exciting. We have a governing board, not only of the member states, but actually the Joint Undertaking is bigger than the European Union. So we have a number of countries that are not member states, that are still participating states in the Joint Undertaking. So in total, we have 32 participating states at this point in time. I then have 3 private members, which is BDVA, we have ETP for HPC, and we also have QUIC. And then last but not least, of course, we have the Commission or the European Union. So we all get together, 36 members in a governing board. I have 36 bosses. It can sometimes get interesting. But the idea is that the Joint Undertaking was spun out of the realization that Europe had chronically underinvested in high-performance computing over years. And you only have to look at the top 500 list to see how it was going. It was other parts of the world that started ranking at the top. And essentially the idea is that by joining forces, by joining the the contributions of national authorities together with the union, together we can buy more. And I don't need to tell you in this audience that if you spend double the amount of money on a computer, you get more than double the performance. The shining example, of course, is Lumi, our biggest computer, ranked as number 3 now on the top 500. And the reason I say it's the shining example is because 11 countries went together with the union, with the joint undertaking to fund that. So if we look at that, our job is to promote HPC in Europe. We're doing that in 3 main areas. One is infrastructure. We're investing heavily in machines, and of course, Lumi and Leonardo are the ones that get all the publicity because they're now 3 and 4 on the top 500, which is great. It's a fantastic achievement. But I do want to say that we have a number of other machines. Carolina is one of them, which is serving the purpose of getting HPC broadened in Europe. So not only you should be looking at those machines as well, because you all have access to them. What we do, we invest in these machines together with participating states. We install them, and we have hosting entities that then run them on our behalf across Europe. And you can all get access to them by applying. So if you go to our website, you'll see how you do that. Predominantly for open science, and industrial participation is welcome. We also do research and innovation projects. So we start all the way down at the chip level. Our flagship project is trying to develop a European processor that will go into a future HPC machine. But we have the middleware, the operating system, we have the applications as well. And then last but not least, training. What's the purpose of doing all of this, investing in all of these machines and all, if no one knows how to use it? So a lot of money is also being funneled into training in HPC, broadening the knowledge of HPC. And of course, one of our projects is a master program in HPC. Now, coming back to, we had a new regulation, new things that the joint undertaking was to take on beyond what we'd been doing on the previous regulation. One of them is hyperconnectivity. This is where I see BDVA really, and just having seen some of these presentations, I think there's so much knowledge here in and around what that means. So BDVA, having joined under the second regulation, having joined as a private member, what that means is that not only does Thomas get to beat me up in a governing board on a regular basis, but more importantly, BDVA is part of what we call the RIAC, the Research and Innovation Advisory Group. And the advisory group, their job is to put together our multi-annual strategic plan, which is what should the joint undertaking be doing, what should be the strategy technically over the years. And that in turn becomes part of our work program and becomes actions that we go out for all of you to enjoy. So I think I've already spent my 5 minutes, but let me just finish by saying I'm joined by Joe Wood and Daniel Opaka. So if any of you wish to speak with us, you're most welcome. And finally, we have EuroCC, which is our competency center project. They have a booth in the far corner, and they can also be very helpful if anyone is curious about the joint undertaking.
Thank you so much. And just please, 1 more minute. Stay with me. I'm sorry, the organizers, or I'm not organizer, but the team will kill me with these improvisations. Thank you. I also want to take to call on stage Lars Nagel, CEO of IDSA. For you, I have to ask you just a minute intervention, but it's a pleasure that he joined us and really making an effort to be here. And Lars, we always talk again about cooperation. Just wanted to, to bring you here and you can say something. Thank you.
Well, thanks a lot, spontaneously once again. Great to see all of you. And I realized it's really a lot of friends. Thanks, Thomas, for your intervention before, referring to the presentation from Dawex, from Laurent. We need really a thorough, compliant, consistent framework to make all these, AI dreams that we do have happen. So thanks to the colleagues to RISE for the analysis of what's happening from the legal perspective in Europe. Well, it's not a joint undertaking, it's a joint endeavor to really bring AI to the road. And well, this is exactly what we need. We need roads for data. So therefore we need something that works for all different domains, for all different sectors, so that we can make AI happen, because AI relies on the biggest imaginable pool of data. And therefore we must, well, grab any data endpoint that we can find so that we can extract value out of it and all the ecosystems that may be behind these data endpoints. And therefore we need a consistent framework, a common data spaces framework for, well, following European values. I like your triangle. So Europe will be trailblazing to, well, set the scene, so to say, and we need to deliver these roads so that we really can make it happen. And this is, well, a convergent architecture which starts very, very basic, well, HPC, so with a bare metal. Then we have the federated cloud infrastructure. We need the semantic data sharing layer. We've heard about that. And then we need all the great smart service scenarios on top of it with all the AI infrastructure or ecosystem that we have here with BDVA. And only in that cooperation that we have with Data Spaces Business Alliance, we can, well, really come up with something new, which will be one of its kind in the world, I would say. And then we can really benefit from all the dreams that we have with AI. So yeah, we all know when we were kids, we wanted to, well, fly to the moon. That was what we were expecting to have in 2030. Well, let's work a little bit on that future together, and let's have a lot of coffees today to make that happen. Thanks a lot.
And also to talk to Lars and the team, there is a booth and you can join. So now I give you time for networking and for a coffee. Just a couple of announcements. First, we need to leave the room quite quickly because it will be split in 4. But also, please check the app for this afternoon program, because there are 2 sessions that were not properly placed on the printed program, and one is related to data-driven business models, a dream or a possible reality in the manufacturing domain. And the other one is the one that we moved from yesterday, leveraging DLTs for new data economy, recommendations to the European Union. So these 2 come in the afternoon, after lunch. Please check the app and enjoy coffee, and see you soon.